So Steve, talk us through, if you would, a bit about this bike and the kind of technology you would have had on here.
Well, yes, there isn't really much technology apart from the fact that this was the state-of-the-art bike in 1978. But as far as electronics are concerned, which everyone talks about at the moment, it's got nothing. It's got a temperature gauge and a rev counter, and that's it. And the only electronics is the spark plug, and it's as simple as that. Very, very basic. And back in the day, the only way if we knew we'd got the bike better, and that would be whether the engine was better, the handling was better, the tyres were better, the brakes were better, was a stopwatch. Simple as that. There was nothing else. There would be probably my girlfriend back in 1978 with a clipboard and a stopwatch, and she'd be timing me going round, and I'd do a 1:37 at Silverstone, and then I might do a 1:36.5, and everyone was happy, and it was near the lap record. But that's where it's an incredible change, and I've been fascinated by the electronics that have come into motorcycles now, and for everything for that matter. And I think for the uninitiated, if you watch Formula One, you know what telemetry is, and it's a way of gathering data and putting it into something that you can actually see. And while I was racing myself, I never had any of that. I mean, I kind of knew from where I was braking, it would be a brake marker and it would be 300, 200, and I knew that at 250 metres I'd be braking, and that was how I judged things. But when I got involved with running the team after I retired from racing myself, I ran the Loctite Yamaha team, all of a sudden we could start to see that where we were gaining this time, and it was absolutely fascinating. I could get the two riders and overlay what they were doing. And Terry Reimer might have been faster than Rob McElnay, and we didn't know quite where, and then all of a sudden we could see, oh well, he's actually faster out of Redgate corner at Donington Park down through Craner Curves. We'd overlay them, and then the riders could actually learn from that because they could see where the other rider was faster or slower.
Sure.
We could then work out whether we were gaining on engine performance, tyres, and so it completely simplified everything that was going on. And now I start to see where we're at with data acquisition, or telematics, what we're talking about now. The system we were racing and using back in the late 80s is nothing like as good as you get on your average car nowadays, which is quite incredible. So I have absolutely been enthralled by what is going on and how much we can gain and learn from all that. And nowadays, on the modern MotoGP bike, which is the equivalent to this but 30 years later,
sure,
they have everything you can imagine. They have brake pressures, they have tyre temperature sensors, fork travels, obviously all the engines. They even have Honda have a system which is called the torque ductor, which is a sensor on basically the gearbox sprocket that knows how much torque is coming out. Okay. It also knows what lean angle you're at. So the latest Honda and Yamaha and Suzuki's, it'll only put the right amount of power in for the lean angle, because it knows when you're leant over, you're using a lot of your grip up on the side force, on the G-force side, and it doesn't want to put the power in. So you could arguably say, and I might as an old racer say, no, it's much easier for these guys nowadays because they don't have to, I mean, our traction control was that, it was the throttle, and as simple as that. So it's now made things so much better. But of course, it isn't just the power. The brakes have got better, the tyres have got better, and everything else. But they can work out fuel consumptions, which is very important. For motorcycle racing, they're only allowed 21 litres. So they can actually make the engine mapping change as the race goes on, depending on how much grip they've got from the tyres and everything else like that. So,
and that's an important point in itself, right? Because a big part about being successful in racing isn't just about flat out speed, right? It's about efficiency, it's about man working with machine. So being able to measure those things and make these continuous improvements must make such a significant difference, not just to the bike and the mechanics and the technology, but actually to the efficiency of a rider, right? And what they can perform.
No question about it. I mean, I'm obviously, my background is racing, but efficiency is absolutely, you're absolutely right, because what you're trying to do is get a motorcycle as light as you possibly can, and I'm using the motorcycle as an example. So you don't want to carry too much fuel because it's heavy. You want everything to kind of last the distance it's set to do, and without some kind of electronics that are feeding that information back, you would never have a clue how that is working. So yeah, and also from a rider's point of view, physical point of view, it's no good getting worn out with 5 laps to go and you've got nothing left in your can as far as your physical side is concerned, and the same with using your tyres when you're supposed to. And jumping to Formula One now, I mean, it's quite remarkable that the electronics, and they can work out their strategy as to what lap times they're doing and what's wearing out the quickest and what isn't, and when they're going to stop for the pits and everything else like that. So what we've ended up with now, I think, on modern vehicles, and certainly with your system, it's a bit like the black box on an aeroplane, and the black box on an aeroplane isn't just for if you have a crash. Obviously, it's there to design and to work out exactly what is working efficiently. And if you've got a vehicle out on the road that's got flat tyres, or tyre pressure isn't as good as it should be, if you've got a vehicle out there that's got a blocked fuel filter or an air filter or something like that is using more fuel. And I don't think in this day and age we can afford wastage, can we?
No, absolutely not.
Everything has to work perfectly. Otherwise, your competitor is doing it better than you. And I think it's so important that nowadays we can monitor what's going on, not just with the vehicle, but with the driver, the conditions, everything that's going on. The vehicle talks to you, which in turn goes back to the person that's operating it, and then to the driver, and he can become a more efficient driver. And I think we all think we're the best driver, don't we? Until we can actually see what we're doing and how we're doing it. And sometimes, a bit like my two riders, you can overlay one on the other and see, well, he's doing a better job than me.
Yeah.
And to me, I'm a competitive person. I want to do a job as good as the next bloke. Simple as
So
that.
as a team owner and manager, at the point that you're using this technology to the benefit of your team, how did you feel about that coming into play, and kind of as a fairly early adopter in the sport of using that type of technology, at what point did you really see this can actually give me a significant difference or enhancement in what we do?
Pretty much right at the beginning, in that all of a sudden we had different parameters to work with. We had different things to start working with. And another great example, because once we got the wheel speed sensors working and we got the RPM working, we thought, oh, maybe we can measure something else. And front fork travel, suspension travel on a motorbike, very critical, because it's all about having confidence in the front end of the bike. Do you know what we used to use? We used to put a rubber band around the fork and watch how far it had been compressed down, and that was it. So we'd know where full travel was, but we didn't have a clue what was going on through the middle of a corner. We couldn't see anything, and sometimes a rider would come in, and I've experienced myself where you've got chatter and the front end's doing it. All of a sudden we put a little sensor on there, and that would feed back, and we could see in the middle of one corner, which you might be doing 90 miles an hour, where the suspension is. If it's at the bottom end of the travel, it's top end, or if it's doing that and chattering around. So straight away that was a way of improving the suspension and that type of thing. Then we'd have a situation, oh, well, if we can measure that, we can maybe measure the front disc temperature. Then all of a sudden you can get your brakes working better and use different pad material. And then we think, right, well, if we can measure that we can then start measuring how much fuel is going in at what point of the RPM, so we can start getting the engine mapping a lot better. Back then it was jets in carburetors and stuff like that. So all of a sudden there was so many bits. I mean, in fact, it got confusing in the early days because we didn't really know what we were doing. But every day we were learning new things. We could even work steering angles out. Every single part comes back in. But of course, back then, some of the systems were really big. And in fact, when I got into full data logging, a data acquisition system, and what we call telemetry in F1, was when I was truck racing and involved with PI, based in Cambridge. And it didn't matter in a truck because the boxes were that big, and it didn't really matter because you're in a great big truck. But obviously now we're down to tiny little components and systems like that, and so it's easy to tuck them away wherever you want them, and the rider, not only a rider can learn from it, but the team in general. If you have a crash, for instance, on a motorbike, and a rider will be going, you know, I've no idea why I fell off. And that's bad, because if you don't know why you fell off, you don't know whether you're going to do it again, and you lose your confidence. Straight away you can go, well, actually I was going 3 kilometres faster on that lap than I was on the previous lap, or I was actually 1 metre wider on a dirty part of the track. And so it actually benefits the rider in that he can establish what caused the accident. Now, if there is nothing wrong and it's him, then he's in trouble. But it's always nice to go back and analyse something that you've done wrong, isn't it? I think, anyway, or certainly from a confidence point of view.
That's how you learn, right?
Yeah, exactly. And that way you don't lose your confidence, because you can actually pinpoint what the situation was and stuff like that. And again, from a team manager's point of view, it was very easy to see if you've got a good or a bad rider, because you could just see the way that they were riding and how aggressive they were riding and things like that, which is exactly where we're at with normal road vehicles now. So it's fascinating. So,
I mean, obviously, successful racer in your own right. Do you think you could have been even more successful had the kind of data analytics and learning that's out there today been available during your kind of early racing years?
Yeah, I think I could, but I'd have to make sure no one else got it. That's the problem,
absolutely.
with technology,
that's the advantage.
Whatever we're doing, you know, whether it's your product, my product, or whatever. If only, you know, we look back, it's a bit like looking at these leathers here. I mean, these are modern day leathers, but when I was racing, the leathers I was riding were like wearing a normal leather jacket. They had no padding in them or anything else like that. These have got Kevlar back protectors in them and all the things that go on. Whereas now, even the modern Grand Prix riders have airbag suits. So as soon as they fall off the bike, the airbag goes off and protects them when they're rolling down the road. In fact, they have in the back of the hump of the leathers, they have a sensor in there for the airbag system, which within a hundredth of a second of you being out of position, it knows where you should be on the bike.
Yeah.
It understands that your body's moving around in this parameter, but as soon as it goes outside of that parameter, that's one trigger. Another is a G-force, another is speed, because it doesn't want to go off when you're doing, you know, when you get off the bike. So it knows that anything under, say, 30 miles an hour, it's not going to hurt you if you fall off anyway. And all these parameters come in that are actually in your leathers now, all electronically fed back to a canister in, and it goes off when you. I'd have been a lot faster if I had one of them, because I wouldn't have minded crashing so much. But yes, I think it'd be very easy to say if only we had that back then. But if we'd have had it, someone else would have had it, and so you'd be in the same boat. But that was interesting, pioneering times for me with the electronic side of it, because it was something that had never happened. Even on road cars back in the days, you know, you had a speedo and maybe a rev counter, and your temperature gauge would be the same as this. It's a wire that goes into the back of the engine, whereas now there's nothing other than electronics. So
yeah, absolutely.
Times have moved on a great deal. Whether it's better or worse, I don't know. But what I do know is that we've all got a great deal more information, so we can actually run more efficiently, and I think that's absolutely important.
Absolutely, agree.